Next presentation, it will be effect of welding parameters on dynamic fracture properties of 2024 T3 and 7075 T6 aluminum friction steel welding joints. Presented by Guo Yaning. Thank you.
Good morning. I'm honored to have this opportunity to present my study, Effect of Welding Parameters on Dynamic Fracture Properties of 2024 T3 and 7075 T6 Aluminum Friction Steel Welded Joints. My name is Guo Yaning and I come from Northwestern Polytechnical University of China. And my presentation will cover as the following parts. Friction stir welding is widely used in the aerospace structure, such as the 2024 and the 7075. These are very hard to connect it by the conventional fusion welding method. And as the aeronautical structures are often subjected by dynamic loadings, it is necessary to study dynamic response of aluminum welded joints. And the former study of our groups has shown that the different welding parameters, such as the rotation speed and the transfer speed, has a big influence on the mechanical micro-hardness of the welded joints. So we use the tensile split Hopkinson experiment to study the dynamic response. And we have the four different kinds of samples and with the different rotation speed and the different welding speed. The samples was cut along the welding direction, and the 5 tensile test specimens were numbered simple 1 to simple 5, which respectively represent the heat effective zone, the advancing side thermomechanically effective zone, the stirred zone, the retreating side thermomechanically effective zone, and the heat effective zone. And this is the stress strain curves of the 2024. We can see that for all of the 5 curves, the yield strength here, these 2 curves are the heat effective zone. The yield strength of them are higher than the other 3 samples, and the peak flow stress here and here is also higher than the others. But the blue curves, which is the stirred zone, shows the highest ductility. And for all of the 5 curves, the peak flow stress is higher than the yield strength. So we can see that the strain rate strengthening effect of 2024 is obvious. And this is the comparison of the different rotation speed. We can see that for all of the 5 samples, the fracture strain of the 600 RPM is higher than the 400 RPM. So we can see that the higher rotation speed generates the higher mechanical properties, because in the welding process, the higher rotation speed will generate the higher temperature, and that will generate the more fine grains. So that is helpful for the mechanical properties. And this is a comparison of the different strain rates. We can see that with the strain rates increasing, the yield strength of the 2,600% is higher than the 1,300 per second. And the fracture strain of the heat effective zone and the thermomechanical effective zone at the advancing side, this one and this one, and the stirred zone is higher than the others. But for all of the 5 samples, we can see that the curves are similar. So the 2024 has the low strain rate sensitivity. This is the stress strain curves of 7074. We can see that it's similar to the 2024. The heat effective zone shows the better mechanical properties. It has the highest yield strength and has the peak flow stress. But it's quite different from the 2024 is the stirred zone. The stirred zone of 7075 shows the lowest ductility. And this is the comparison of the different welding speed of 1775. The yield strength, the peak flow strength, and the fracture strength are also similar. So the different welding speed does not generate a significant change in the flow stress and ductility. And this is a comparison of the different strain rates of 1774. That is different from the 2024. The other four samples are similar, but in the sterile zone, the 1775 is not less sensitivity. And this is the comparison of 1775 and 2024. We can see that the yield strength, the peak flow strength of 1775 is higher than the 2024, but the fracture strain, the here and here of 2024 is better than the 1775. So the 1775 shows the better strength, and 2024 shows better ductility. And this is the fracture morphology. We can see in these two pictures, the solid state stirring effect results in the fully recrystallized and increased grains in the sterile zone. And especially in this picture, the 1775 sterile zone shows clearly three distinct zones: the crack ignition zone, the crack growth zone, and the transient crack zone. And the morphology of the fracture surface indicate that these two pictures, the brittle failure mode is dominant in the two strain rates, but it's not quite different in these two pictures. So we can see that the 2024 sterile zone, the mechanically of these two different strain rates is not very quite different. And this is the thermomechanically affected zone and the sterile zone of 2024. We can see that as the function of the welding tool, many cross-stitch shaped participants are found, like here and here. And the fracture surface of thermomechanically affected zone exhibits small and shallow dimples here, and it indicates it's a ductile and transgranular fracture. But the sterile zone has the increased and fine grains. So for the aluminum fracture, it always happens as the voids grows. So the thermomechanically affected zone of the 2024 has the worst mechanical properties than the sterile zone. And this is the heat affected zone of the 1775. We can see that there is a population of voids of varying size and shape distributed through the fracture surface. And there also have some second phase particles. It's not clear here. So we can find that there are also the transgranular fracture. But the sterile zone shows the cleavage fracture with tiny particles. So as the function of the second phase particles and the heat effect zone always have some base metal material, so we think that that's the reason why the heat effect zone shows the better mechanical properties than the 1775 sterile zone. This is our conclusion. For the 2024, yield strength and the peak flow stress of the heat affected zone is better than the sterile zone and the thermomechanical affected zone. But for the 1775, the flow stress of heat affected zone is higher than the others, and in the sterile zone, the fracture strain is much lower than the others. And under the same welding speed, the hair rotation speed leads to more refined grains, and shows the higher strength of extension and ductility to the sterile zone. But the different welding speed does not generate a significant change in flow stress and ductility. And at the room temperature, the 2024 and the 1775 is found to be relatively less sensitivity to the strain rate. And the fracture surface of thermomechanically affected zone and heat affected zone exhibit small and shallow dimples and indicate a ductile and transgranular fracture. And in the steel zone, the fractures exhibit relatively smooth surface, which contains many cracks that are characteristic of brittle fracture. And thanks for your attention.
Thank you very much. Thank you.